start with our definition of what a right triangle is in a square. We have the relationship of area of the square and the side length. We've just cut out our squares. Each square, like I said, you're putting your area inside. So when I get to the green one, which was a 5 by 5, right? And I'm looking at this green square, right? And I'm looking at that one, the two things I'm going to see on your paper for that green 5 by 5, I'm going to see the 5 by 5 was a 1, so I'm going to see a 1 on your paper, right? The other thing I'm going to see on your paper is that you are then going to put area of the 5 by 5 was 25. Do it on the side where the squares are, right on that same side. And then the side length was 5, right? So each square should have those two things on it. It should have a number, either a 1, 2, or 3 label that they told us, right, from here, that I have up on the board also. And now I have area and side on it too, right? They're all nice numbers, right? Because we were given the side lengths of 5 by 5, 6 by 6, 8 by 8, okay? So what we are going to do next is that pile of 1s. You're going to use only the pile of 1s, set the pile of 2s to the side, okay? So any of your 2s, we're just going to put that big pile of 2s and set it to the side. So everyone have their pile of 1s. Green is on the bottom, right? Then you got yellow and pink on top of it. So I am looking at these 3 squares, and this is what it says on the top of the next page of your notes. So turn to that next page in your notes, because we got to write a few things down as we do today. And it says this: can you make a right triangle with sides of the square for group 1 and for group 2? So thus I want you to use group 1 first. And someone said, I don't get what you mean make a right triangle. So here's what I want you to be thinking of. If I would be putting edges together, I can't put like these two together like this as you see this, right? I cannot put them together like this, okay? But I can put them at vertices, and I'd like you to try and see, keeping the squares up, can you make a right triangle? And we're going to show these under the document camera, okay? In our triangles, we have the yes and no. It says, use the following procedure in group 1 only. Then do it again with squares, group 2 only. So just the group 1s again. All the ones with 1s, put those out. Without overlapping, can you cover the largest square? The largest one is what color?
Green.
Green. So put the green one on the bottom, okay? So when you have your green square, can you cut up the smaller 2, the pink and the yellow, to cover it? So make sure you cut along the lines, right, so you have nice lines. And you're going to see if this will work for group 1. So do this now. Take your green. Which size green am I talking about? 5 by 5 or 8 by 8?
5 by 5.
Ah, some of you, I saw that big 8 by 8. I want the 5 by 5, right? That's the green one. That's on the bottom. This is for the 8 by 8 down here. So everyone's only the green 5 by 5. No 2s. I don't want any 2s. Move all the 2s to the side, okay? And you can cut apart the 1s. You're going to do the 1s and you can cut them apart. You can cut along those lines to cover that green, okay? Once I have a few people with theirs, we're going to put it under the document camera. All right, so we said yes, right, to this
Yes.
group 1 was a yes. And group 2, you guys definitely said no. And here's what we were looking at, okay? So this is on that part, and some of you might have taped. So where we writing this yes and no on that top half, I want you to put the green area. Green area. What was our green area of our first group?
65.
5 by 5, 25, right? Was equal to, right? The pink area. What was our pink area? It was a 3 by 3 or 9. And do you agree plus the yellow area? And our yellow area was a 4 by 4, right? So it was 16. Do you agree that 9 plus 16 always equals 25?
Yes. What? No.
9 plus 16 is 25, right? Right, yeah. Okay, but in group 2, what was our green area? Our green area was 64, right? In group 2, it was a 64, 8 by 8. And the pink area was still 9, right? 3 by 3. And the yellow area in group 2 was a 6 by 6, which meant an area of 36. And 9 plus 36, is it ever going to equal 64? No, it's going to equal 45, right? But 45 is never equal to 64, right? So when we are looking at that, that's how we kind of know about those areas. Now, what's going to happen with this? At the end of this unit, you are asked, show some different ways to prove the Pythagorean theorem. And you're going, at the end of this unit, it's a pretty short unit, but people go, oh, I know what this theorem is and I just want to apply it. What I need from you is how do you prove it? And this is one easy way, right? We could cut apart the area of the square. It's 3 by 3, 4 by 4, and it covers this 5 by 5. We cut it apart and we actually saw that work, right? So that bottom half of your notes, right? We're almost done. It says, does the largest square equal the sum? Equal the sum, that's adding, of the two smaller ones. So this is what they're asking. Does the green, that's our larger one, green area, does it equal the sum that's adding the two smaller ones? The pink area plus the yellow area. Did it work in group 1? Yes. We had 25 was equal to 9 plus 16. Did it work in group 2? No, because 64 is never going to be equal to 9 plus 36. So it says, what relationship do you notice in the sets of squares? Okay, what relationship do we notice in our sets of squares? If it's a right triangle, only if it's a right triangle. If it is a right triangle, then we are going to say the sum of the two smaller areas, equals the larger area. And the question that I ask some students is, well, does it work with the side lengths too? Okay, so we know that 9 is an area plus 16 is an area. These were all areas, right? 9 plus 16 equals 25. What were the side lengths? The side lengths were, if the area was 9, the side was 3. Is 3 plus 4 equal to 5? No, never, right? So it only works with their areas, okay? The key thing is it only works with the areas. So, well, what would happen if the relationship of the side lengths was changed to 2 on our yellow square? So our pink one, right? We would find the area of the pink. Pink area would still be 9, right? Plus our yellow area. What would our yellow area be now? 4. So 9 plus 4. What would our, if it's going to work to be a right triangle, what would our green area have to be? It would have to be 13. And if the green area was 13, what would the side of that be from the beginning? What did we do at the beginning? Faith, that has?
It would be the square root of 13.
It would be the square root of 13, right? So you're going to have some that don't come out rational, right? You get irrational. If it's a perfect square, they're all rational, okay? So turn in your workbook. There are 2 questions. When are these 2 questions due? Not tomorrow. Thursday, okay? Tomorrow you're coming in and it's test day right when we walk in. We're going to start you on number 1, and then you can do number 2 on your own. There's only these 2 questions, right? So it's easy. What I need you to do off of the right triangles, I need you to draw squares off of each side. Okay, so draw a square off of each side. Try to make it a square, not a rectangle, but again, I'm not going to look for perfection, because obviously, you can see my drawing abilities when I'm not standing at the board. It's easier. Making
There's the rock, there's this little line thing that you can like use.
I know, I use that sometimes too, but sometimes
Does
that's,
it just take too long or?
no, it just, I want you to see my creativity. Alright, so it starts off the problem, it says side A is 8 inches. So down here, right in this box, side equals 8 inches, right? Just like we did on our cut up ones. Sam, if the side is 8, what is the area?
The side is 8, the area is 64.
So 64 inches squared. Okay? Everyone good with that so far? Okay. Side B, they tell us, Ian is what length? When you read the problem. 6 inches. So in B, please make sure everyone's drawing their squares. B, we're going to put side equals 6 inches. So that means our area has to be what, Jeffrey? 6 inches squared. Okay? And if they're asking you to find C, and what did we just find? That the sum of the two smaller ones equals the larger one. So we're going to put area of A, which was what? 64, plus area of B, which is 36. That has to equal the area of C. And the area of C is going to be, what's 64 plus 36?
100.
100. So, in this square over here, I'm starting with area equals 100. Can I find the side length?
Yeah.
Because they don't ask what the area is. They said, what's the side length? So what does C have to equal?
10.
10 what's our label?
10 inches.
10 inches. Okay? So you're going to do number 2 in the same way. Draw the squares off. Okay? Find the, do the same thing. Area of A plus area of B equals area of C. You can't